We live in an information and data-rich world and use graphs to display data visually, helping us to understand it. When drawing graphs, it's essential to choose a type that clearly shows what the data tells us, without any further explanation. Getting the labels and scale right makes a big difference. We want the data to be clearly interpreted so that it has maximum impact. Tables and charts are often used to collect data. A frequency table is used to organise the data and show the frequency of an event, how often it happens. This can then be represented in a bar chart or a vertical line chart. Charts like these are used to display discrete data, which is data that can be counted and categorised. A multiple bar chart is useful when you want to compare data for two or more groups. Pie charts and composite bar charts show different parts of a whole or proportions within the data. Pie charts are always circular and have a sum of 360 degrees. A composite bar chart also shows proportions, for example, monthly sales totals. Each bar can then be broken down into the different categories of sales made. A scatter diagram is used to show whether or not there is a relationship between two sets of data. This is known as a correlation. Data that is collected in pairs is known as bivariate data. For example, a research project designed to see if there is a relationship between time spent studying and exam results can show its results on a scatter diagram. We would hope that this would show a positive correlation and be evidenced through a line of best fit. Graphs help us to make sense of the world. Take a look at this example. The title explains the story, and the labels let you know what the graph represents. The shape of the graph lets you know how the relationship changes. How high does the helicopter go? How long does it stay at a height of 300 meters? How long does it take to land? Linear and quadratic graphs are a little more complex. They have perpendicular lines that intersect, known as the x and y axes. X is the horizontal axis and y is the vertical axis. They can contain both positive and negative values. Where the axes intersect is known as the origin. Linear graphs are used to compare trends and relationships between quantities. They are said to be in direct proportion if they intersect with the origin. To plot coordinates on a linear graph, you may need to work out the equation of the line using your knowledge of algebra. Here's an example of a graph that is strictly vertical, and this one is strictly horizontal. Other linear graphs may slope and show a gradient. If you substitute a value for x, for example any number between 1 and 5, can you tell which would be the steepest? Let's try to solve a problem. Panagiotis is an electrician. He has a call-out fee and then charges for his time. The price of the complete job is A, and the amount of hours the job lasts is H. Using this graph, can you work out the formula? What is Panagiotis' call-out charge? What is his hourly rate? Yesterday was Sunday. He charges double for a call-out on Sundays, but the same hourly rate. He charges £330 for one job. So, how long did he work? The equation we use to express straight line graphs is y equals mx plus c, where m and c are both numbers. M represents the gradient of the straight line. A positive value for m means that the line slopes upwards from left to right. The bigger the value, the steeper the gradient. With a negative value for m, the line slopes downwards from left to right. C represents the y-axis intercept, where it crosses the axes. Some graphs contain curves known as quadratic curves, cubic curves, or parabola. Quadratic curves are created by equations that contain x squared terms but no higher terms. For example, x equals minus 3. Cubic curves are equations with x cubed as the highest power of x. A parabola is a plane curve which is U-shaped and is mirror symmetrical. The path of a projectile under the influence of gravity follows a curve of this shape. Let's take a look at some examples. To plot the quadratic curve y equals x squared between minus 4 and 4, we can use this table to help plot out our points. To plot the cubic curve y equals x cubed between minus 4 and 4, we can use this table. Can you plot the following linear graphs? If you can, have a go at something a little more complicated. Can you plot these in a graph?